You're playing golf. If you're playing golf, do you want a high percentile or a low percentile? You want a low one because you don't want more people lower than you, because low in golf is good, which just seems unnatural, but we'll just deal with it. So in this one, it's running a race. No, I'm sorry. Yes. Runners in a race, a low time means a faster run. That makes sense. So if you're looking at times, do you want to be in a higher or a lower percentile? Time that it took you to run. You want, yes, exactly. You want fewer people to take less time than you. You want more people that took more time than you. So you want a lower percentile. You guys, semi with me. Let that just make sense. You're so used to tests and getting higher and higher, but golf, you want lower scores, right? So let's see. The winners in the race have the shortest running times. That's amazing. I don't know if you realize that. Is it... I don't know why they wasted space for that sentence. Is it more desirable to have a finish time with a high or low percentile? We just answered that. Lower percentile for running a race, because then fewer people ran quicker than you did. And that's what you want to have happen in a race. I like it. So where things get weird? 26B? C? Okay. So you're like, come on, dude, come on. So let's just go right to C. A bicyclist in the 90th percentile completed the race in 1 hour and 12 minutes. So this bicyclist is in the 90th percentile, and they completed it in 1 hour and 12 minutes. Is this person in the fastest or slowest cyclist in the race? Would you say they're a faster cyclist or a slower cyclist? So in the 90th percentile. So yeah, so 90% of the people took more or less time. 90% of the people took less time. So he's definitely slower. It took him longer to complete this race. Write a sentence interpreting the 90th percentile in the context of the situation. So how could you, could you use this time and this together in a sentence somehow? So he's the slower one. So 90% of the people took less time than this. Or even 10% took more time than this. I would accept either one of those. So it's really just analyzing the idea of percentile fully. You got to realize, is it high good or low good in this situation? That's going to change your opinion of this. Is this good when we're talking about cost of a car? No. Is this good when we're talking about rating of a car? Yes. So if you found a car that this was the cost of the car, that's where it is, and this is the rating of the car,
it's a pretty good car.
Buy that car. Right? It's like, shit, yeah. All right. Maybe look at the history for that car, but still, that looks pretty good. All right, you guys kind of with me? You just got to know the situation, know which one's good, 90 or 10, or, high or lower. Is it better or worse? Anything else from homework stuff? Can I ask you guys a question? Are you doing homework? Yes. Some of you are. Good. But maybe for some of you guys, maybe it's going really well. That's awesome. And on one level, especially with chapter 1, it sort of should. It's just a bunch of definitions. You just got to get used to them and how to use them. Chapter 2 is not very intense math yet. It's coming, but it ain't here yet. But still, if you have a question on something and you're hesitant to ask because you think nobody else has any trouble with it, you're wrong. Other people are going to have the same questions, so you should ask questions. If there are no other questions, I'm just going to get back into where we left off. Yes?
I had a question on how you did 24.
Oh, good. All right. So the mistake people make on 24 gives you all these ages for Academy Award winners, and they sorted it for you, which is nice. And they say find the percentile for 37, right? So there's two different ways. There's one way, the book way, which is really kind of convoluted, and the second way is a lot more straightforward. So I'll show you the second way. Because either way is actually accepted in real life. People do this that's wrong. That's not what they're asking. They're not asking for this 37th percentile. They're saying, what is the percentile for this age? So look at the list. It starts off at 18, right? 18, 21, blah, blah, blah. And then 37 is in there somewhere. There's 37. Blah, blah, blah. And it goes up to 77. So if somebody was aged 77, what would you say? What percentile are they in? What do you think? What percentage of the people are aged below them? Almost all of them. So it's sort of P100. Depends on the way you look at it. But yeah, so it's sort of P100. You guys get the idea? So 37 is sort of like here. I think I represented it sort of right. Well, it's more like in the middle. So it should be close to P what? If it's right sort of in the middle? 50. So I'm not given a percentage. I have to figure out what the percentage is for that data point. So how do I find a percentile? I take so much percent and I go that far into the list. So I just do that backwards. How far into the list is that number? How many numbers are in that list before this? And see, the reason the book has it more convoluted is it takes into account the repeats of it. But there's a way of looking at things that if there's not a lot of repeats, you don't have to worry about that. So it's only if there was like a ton of repeats. So if you count how far it is and then divide by how many numbers there are, that will give you a rough estimate for what the percentile is. Because that's the idea of a percentile. It's a percentage that's below your score. Does that make sense? A little bit? Or you could do the formula in the book. If you look at the book's formula, you could apply it. That's fine. And they're just being careful about repeats. Because there are a couple 37s. Right? Okay, maybe. Is that cool? Who asked that question? Does that make sense? Where are you at?
So if there is a repeat, you just count it once? Or
No, so like what I would do is I would say picking this one and then count all these that's below it. Yeah, just to be on the safe side. But here you've got a bit of there's some flexibility here, and the book goes one way, which is the more technical way of doing things, and then there's a slightly less technical way. I would only use the book's method if there were things that were repeated 4 or 5 times. Because then it's like, where are they in the list? I have to be a little more careful. And the book's formula is this little dude here. Here it is. Where y is the number of times it's repeated. Yeah, okay. And to me, this is kind of, the reason I don't like this is because then you're less connected to the idea. If you just do this, that's the idea of percentile. What's the idea of percentile? That percentage is below me. So how do you figure out your percentile? Well, how many are below you divided by how many total? That's the percentage that are below you. It's a very direct use of the concept of percentile. Okay? So math is not just knowing a bunch of freaking equations and plugging shit into it. That's really not math. That's why I don't like this. This makes it feel like that's what it is. Math is about applying concepts, creating equations that use those concepts. So this, right now, all I really want you to use is use the concept directly. How many numbers are below yours, divided by how many total, gives you a nice rough estimate of what the percentile is. Because that's the idea of percentile, right? So this is how this class is going to work. If you're coming in here, you should be worried if you have to memorize a bunch of formulas and just plug it in there. Oh, that sucks. That desperately sucks. I teach concept. I teach idea. Sometimes that's painful. I don't care. Because if you don't get that, you don't learn. You're not learning. You're just plugging and chugging. That's not learning. All right, cool. Maybe. I'm scaring some of you guys. Oh, well. All right, any other questions from homework that I can scare you about? Okay. Shut that down pretty quick. Is somebody actually sitting there?
yeah.
Yes? Okay. Are you okay back there? Are you... Oh, there's one under the screen. I don't need this guy because I don't even have a way to turn that on. Cool. All right, so... Anything other from homework before I get back? The last thing we did was box plots. So I think I want to let you guys do a quick box plot problem, just to see that we remember how the hell to do it. If you weren't here last time, we also did histograms. If you want to look at that video. So I want you to find the 5-number summary and then create the box plot for this. This data here. What you got, Jeff? I don't know, Jeff. I'm going to be nice. I'm going to put it in order. Okay. Let's say these are golf scores for really horrible golfers. This guy broke a few of his clubs on the way, so his scores just get worse and worse. Anybody golf? I think I asked this already. Yeah, that's right. I don't mean to speak down about golf. I really don't. So don't take it bad. So just to make sure everybody's on the right track, remind me, what is the 5-number summary? Low?
Q1 and the quarters.
And then the quarters. I like it. Q1, Q2. Q1 is another name for?
25%.
Beautiful. P25. Gather. P75. P75, P50. Thank you. From the bottom to the top. Okay. Like it. All right, let me just do this one. Just make sure everybody's on the right wavelength here. How do you do? Well, low is either. High is either. What about P25? What are the 2 steps?
25% and 14.
Good. So the first step is where is the answer? The second step is go get the freaking answer. All right. So what's 25% of 14? Because there's 14 data points. What does that equal?
3.5.
3.5.
4.
Here, you're going to need these later anyway. If you need a calculator, which you shouldn't for that problem, but hey, I won't give you too much shit about that. There's some here. 14 divided by 4 is 7 divided by 2 is 3.5. What does that mean? Here they come. Please remember to give these back to me so I don't have to buy new ones.
Nope.
What's up? That's it? Share. If you would have just come up here yourself, who knows? You might have got one. Could have fought with somebody. I'm sorry. So what does that mean? What do I do? Good, right? Round up. Always round up. Even if it was 3.01, you round it up to 4 and you take, that's where the answer is. Don't just say this is 4. That's crazy. How could it be 4? 4 is way the hell below that. So the fourth one in, fourth number, is the answer 1, 2, 3, 4. So it's 82. Q1 is 82. And you'll just do that same thing. Just got to remember, if it comes out to a whole number, what do? Average that with the next one up. I like it. That's going to suck a lot, but I can't. Oh. I'm going to slowly catch up to here. So the average, 7th and 8th. 8, 7, 8. Wants to be 85 and a half. You guys see that? So why did they do something different here than they did there? It's all about what kind of number you get. You get a non-whole number, you round up, and you take that number. You get a whole number, you average it with the next. Yes?
With the next up or the next
Next
down?
up. Yeah, the next number. If you remember, there's a shortcut for Q3. Yeah, if I have to count 4 places in for Q1, I gotta count 4 places down from the top for Q3. Or you can do 74% of 14, blah, blah, blah. So I just count 1, 2, 3, 4, it's 91. Oh, I got you.
What is it? 1 and 2?
No? What's the 4th number in? From the top? 1, 2, 3, 4. Right? So if you do it the other way, what's 75% of 14?
Okay.
10.5.
10.5, so you round up to 11. And that's the 11th number. Cool. All right. Now that works for every percentile. If I ask you to find P62, you would do 62% of however many numbers you got. See what number you get, and that tells you where to go to get the answer. I like it.
So you
Yes.
said to always round up, even if it's like something 0.2?
Yep. Even if it was 3.01, you take the 4th number. If it's a whole number, you average it. If it's anything else, you round up and take that number. I like it. So see, percentiles are not perfect little measurements. The larger your sample is, the more sense they make. If my sample had 2 numbers, I'm not going to have, there's no way I can have a P10 and a P20 and a P30 and a P40. There's going to be a lot of repeats. It's not going to make much sense. The larger my sample is, the more sense it kind of makes. So it's sort of an estimate for very small samples. So my 5-number summary is this. Bam. So how do I use that to make a box plot? Box and whisker. What do I do? That's crazy. Plot them. It's part of the words I like. But how do I make my number line? How do I make my scale? Do I just put these numbers on it?
Start behind the low.
Yeah, so I know I have to get 71 in there. So maybe I'll start at 70, nice round number, right? I'll start at 70. So then 71 has a place to live. Aw. And I want to get up to 121. So maybe I go to 125 Fives might be a little too much, but let's see. 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125. All right. I like it. Cool. I like it. And then you just put lines representing those numbers. I like it. And it's just a really quick way to make a visual display of your data. You can compare it to other visual displays very quickly. So this is one group, how they played golf. There's 71. What do I need? 82. Boop. 85 and a half. 91. 121. Pop. So if I just gave you this picture, do you see how, what can you tell? If I didn't give you the numbers, I just gave you this picture, can you see how you can tell that 121 dude? Is he with a lot of people out there, or is he by himself a little bit? He's kind of an outlier, right? Outlier. Most of the data, in fact, how much of the data is in that little box? 50%. I love it, because that's Q3, Q1, 75% below, 25% below. There must be 50 in the middle. I love it. So that's the middle 50%. So these are not good golfers. I almost said golf players. That doesn't sound right. Good golfers, but they are kind of consistent. Do you see that? This isn't big. There's like a little chunk that kind of scores. They score close to each other. And then they have, this guy had just a bad day, right? Didn't have his coffee in the morning. Just everything sucked. This guy's like, oh, show off. But even he's not that far away from the group. All right. So if I showed you another picture, not even any data, I said, here's another group of people. Same scale. What could you tell me about this group of people? They suck even worse, right? But what's one thing about sucking that these people have over these people? They have at least one person that sucked worse than all of them, right? But I would say this group is the suckier group, just to make that adjective out there. Okay. Yeah. Now, also this group had better players and they had worse players, but these overall, I said that the right way. These overall were certainly the worst. Like, you guys understand that? I mean, I didn't even give you any data. You can still compare it to another group and tell me stuff about it. That's the quick visual we can make. All right. And really, chapter 2 is mostly about how can I display my data quickly so people can tell what my data looks like without just looking at a bunch of freaking numbers. This is much more explanatory than just looking at the numbers. Okay, that's enough about that. All right, so any questions on percentiles, quartiles, box and whisker plots? Or just box plots? No, okay. All right, we know more than we wanted to, Jeff. We have no questions, okay. So, I'm going to get into our first little formula, our first real formula, and it's for a simple little thing. We all know how to do this. Can somebody say in English, as opposed to Mathish, in English, how do you find the average of a set of numbers? We're going to use the word mean real quick. I heard you. So you add them all together. So in English, you add all up. Divide by the number of data points, right? Just to be a little technical. So the number of data points. Now depending on your 103 or 110 teacher, some of you guys saw this notation already. Some of you haven't, so I'm going to assume everybody has it, just to be on the same playing field. There is a beautiful little symbol that means this. Exactly, cool. It's the Greek letter S, because math people are really, really creative, and they said, some starts with S. let's use the Greek letter. Yeah, sure. So add them is this. This means add and is waiting to be told what to add. So it's sort of like a square root symbol just sitting there. That doesn't make a damn bit of sense yet because I haven't said what to take the square root of yet, right? This doesn't make any sense yet because I haven't put here what to add. Now what do I use to represent in algebra when I have numbers that do you even know what the numbers are yet? No. So how do I represent them? X. That's the variable. It's allowed to vary. It can take on a lot of different values. So now I'm going to say it's going to take on all of my data values. So this is from algebra. I use the letter X. Yay. Add up all the data points and divide by the number. So what letter do you think I'm going to use for that? No way. All right. Not Y, N. Oh, why do we use that? Because we wanted to. I wasn't even there, so hell, I'm cool with it, but I didn't get a vote. I wasn't there when they made this up. And this, the symbol for, there's two symbols for mean, because there's two things. How do I analyze information? If I analyze a sample, what kind of numerical description will I get? A statistic. I love it. You guys see where I'm going. If I analyze a population, I'm going to get a parameter. So I want my symbol to tell me the difference between the two, so I don't have to have somebody tell me. All right, math people, we would love a symbol to tell us a lot of shit. So this is all of that written very quickly. That's what math really is, a shorthand. So instead of saying mean, I say, you're going to love this. Do we know how to pronounce that? Mu. I call it like a French cow. So this is a population mean. So for populations, it's sort of like the Super Bowl, except for this last one. So for like Super Bowl 49, how did you see the graphic when they said Super Bowl 49? You just remember, what do they always use? Did they use the number 49? They use freaking Roman numerals. Now, of course, for Super Bowl 50, they would have just used the letter L, because that's the Roman numeral for 50. So you didn't see a bunch of L's dropping. L, the shape, and the rock shape. Bam, Super Bowl L's. Doesn't sound like Super Bowl XXXVI. You see what I'm saying? So, what does it got to do with this? When I want to talk about a population, that's the population. We use Greek letters to be like, oh yeah, that's officially the population. When we just have a sample, we use our letters. So instead of using mu, we use X bar. Alright, so really pay attention to what just happened. These are both the average. You use this symbol if it's a whole population that you have. You use this symbol if it's just a sample that you have. So it's if I said, I just conducted a study and I found this, well, who did I research? Everybody. Whatever the hell the population is. I researched everybody, so I better freaking mean that shit. Oh crap, I mean that. I just took 20 people, leave me alone. So it's a quick way of communicating something to somebody else. All right. The book, I think, uses a capital N for like the population simp, and that's dumb. N means the number in your whatever you're looking at, period. So I'm just going to use a lowercase n. Okay, cool. It already gets Greek symbol. Why does it get capital N? No, it's getting greedy now. All right, so the average obviously measures the what of the data. What does the average give you a sense of? What do you think? If I say the average age in here, where is that age related to everybody else? Somehow it's in the middle in a way. So let me give you a situation where that's not really true. If I said if I was going to start working at a company, and I said, what's the mean, let me just start using the actual word we use here, the mean income for everybody at this company. Is that number going to give me a sense of how much money I can expect to make? Why not?
Is there more people that make more than others?
Well, not really. There's actually less.
Depends on your role.
See?
Depends on your role.
True, but now they just give me the average of everybody that works at the company. Who works at the company that's going to throw that mean off? boss, the CEO. Now, of course, it kind of depends on the company, but nowadays, especially, most CEOs make upwards of 10 times as much as their average employee, right? So if I had another place that happens more immediate, you go to La Jolla, and you go to the beach, and then you're walking around, you're looking at the houses that you're like, maybe I'll get invited in there someday. That's what I think anyway. You guys might just don't become a teacher. Maybe you'll make more money. I'm cool with it, but I'm like, well, all right, it's not going to be mine. But when they describe prices of homes, they don't use averages or means because it's not representative. It's skewed too much by these higher priced houses. So if I had a company where this is in thousands of dollars, one guy makes $37,000, another guy makes $42,000, somebody else makes $50,000, and the CEO makes $450,000. Real quick, what's the mean of those numbers? We'll say this is a sample, so what I'm going to use the symbol X bar. And that is how you say, I don't know if I said that, that's X bar. That's how you say that. That's awesome. It's an X with the bar. So we call it X bar. We're creative again. All right. So somebody got that going? 29, 5, 39, 4. Do it again.
44,000.
So if you tell somebody, the mean income here is 144,000, and they're like, holy shit, damn straight. So there's got to be a better way to describe incomes, home prices, stuff like that, right? That have these extreme values, they're going to throw it off. So there's another thing that I can measure.